Hello, everyone. Today is Wednesday, 5th of July, and this is the Cluster API office hour. Before starting, usual reminder that we abide to the CNCF code of conduct, so please be kind with each other. We have a meeting agenda, and please add your name in the attending list, and if you have topic, feel free to add them to the agenda below. If you don't have access to the document, you need to join the SIG cluster lifecycle mailing list, and you feel free to ask in chat, and we will provide a link. Okay, so I think we can start. As usual, at the beginning of the meeting, we give room to new attendees to introduce themselves. So if you are a new attendee of this meeting, you want to say hi to the other folks, just raise your hand using the button which is under reaction in Zoom. Okay, it seems that there are no new attendees today, so we can move to the meeting agenda. Mike.
Yes. This is something I was thinking about recently as I was doing some carpenter kind of hacking and whatnot, and I was wondering if it's a topic that's ever come up here. So for a little background here, that one of the things that auto-scaling applications like the cluster autoscaler and Carpenter like to do is an activity that they call balancing, right? And balancing is the operation of telling the autoscaler that you have multiple zones or regions, and you would like to make sure that, as new instances or new nodes are created for your Kubernetes cluster, that they're balanced across these zones. Now, in the cluster autoscaler, we handle this by, every scalable resource type, like a machine deployment, is a node group. And so the autoscaler has some logic to try and detect similar node groups, and then it will try to make sure that those are balanced. And Carpenter has a similar mechanism as well, although it looks at the way it looks at the instances and the data is a little different. So I was wondering, like if I'm a cluster API user and I make a machine deployment that uses a specific instance type, and now I want to be able to have that replicated across 3 or 4 different zones, my option, as I understand it, is to copy the infrastructure machine template multiple times and give each one a different zone. And then I would have a different machine deployment for each, scalable resource that I want. So what I'm wondering, though, is has anyone ever thought about the notion of, you have a machine deployment that could have things in multiple zones, or maybe there's a way to indicate that I've got several machine deployments and they're all the same. The only difference is they have different zones or something. Is that a topic that's ever come up here, or a use case that users have ever, kind of raised as an issue, I suppose?
Is there someone that wants to answer to Mike?
I'm guessing the silence is no, that this is not something that has come up for anyone before.
No, so historically, we basically had a control plane which have different failure domains, and a machine deployment always had only one. This is what historically is there. Then so far the answer has been, oh, just create more machine deployment for different machine zones.
I guess has there ever been have users ever kind of complained about the process around like multi-zonal deployments or something like, I want this thing to be in multiple zones, and that means my work, like if I want to have 3-zone deployment for everything, then that means that I have to triple the amount of records or manifests that I make, right? Because I got to make 3 infrastructure templates, 3 machine deployments. I guess we've never had users kind of complaining about this as a usage pattern.
There was false asking, but as far as I'm aware, never a push to get a multi-zonal machine deployment.
Okay. You know, and really what caused me to think about this is that in Carpenter, the way that you represent machines to the core Carpenter library so that it can kind of make decisions is that you have an instance type and then you'll have a list of offerings that go with that instance type, right? So you could imagine, you know, on AWS, maybe I've got an MX6 or an M6X large or something, right? Like one type of instance. And when I get that back in Carpenter, it might represent that instance as a single instance type, but then it would have a list of offerings and it would say, yes, it's available in this zone at this price, and it's available in this zone at that price. And there might be a list of these. So like it wants to view the instance type as one thing and then vary it by zonal information. And so as I'm writing the logic to kind of bring this in for cluster API, you know, what I'm doing is, okay, well, I have to look at each machine, like I'm basically looking at each machine deployment and creating a single offering for each one because each one can only have one offering. But this is one of the areas where it might be better in the future if there were a way to say, well, these machine deployments are all the same essentially. The only difference between them is the zone that they're in, you know, and that's not data that cluster API necessarily needs, but would be really useful for other applications that use cluster API, kind of, you know, cluster API consumers, as it were. So I get that's not a very good pitch for like adding a feature to cluster API, but I'm kind of describing the context around what, you know, the problem I'm looking at and everything. And I really hope Chris's cat has a good answer for me.
Yeah. Uh, yeah. I got what you say. I'm the issue. I think that the issue that should be addressed is that the definition of same is way different across every infrastructure provider. So what is same? It is same instance type or same instance plus 20 other knobs that can make the machine different. So I think that's the notion of same is a tricky one. If we find a good way that work across provider, why not?
Yeah, I
And
mean,
you can make the Carpenter integration smarter and basically look at many machine deployment. They are the same, but it creates only a unique offering with different zone.
yeah. Yeah, right. Or if there was a way, I mean, or if there was a way to have a machine deployment that I could say, like if there was a way to have an infrastructure machine template that could somehow have the regional or have some templated information that could come into it, you know, at the time of creation, then you could say, well, we've got one infrastructure machine template and one machine deployment, but the machine deployment maybe defines multiple options, you know, that could be injected into the infrastructure machine template at creation or something. I see, you know, Christian and Matt have their hands up. So please, Christian.
Yeah, the disclaimer before I say that, I think that would be a misuse of the functionality, but the definition of what a zone is basically done by an infra provider, right? CAPI doesn't restrict the infra provider to say, hey, I provide this zone, and this zone is US East 1, 2, and 3 together, or something like that. And the machine deployment just creates a machine in that US East 1, 2, 3 zone, and the infra provider then has a way to pick up which zone it deploys to or something like that. So that would be one thing. But I think that would be not, yeah, that would be kind of some kind of misuse of that functionality, maybe. Yeah.
Yeah, I totally get that, you know, and I don't want to propose something here that's like, oh, this is a hack that we could get in. I'm just, you know, kind of thinking about different use cases and whatnot. Matt, please.
So again, not directly, I think what you're looking for, but possibly related. I've been thinking for a while about how we could implement a new API for failure domains. And I had a proposal somewhere. This is a highly speculative proposal, which will probably never happen. But essentially, it treated failure domain somewhat similar to how the cube scheduler treats pods. So you create a machine, and it references a policy, but it has no specific implementation attached to it. And then if you create one of these, you're then reliant on some of the controller coming along and populating the information that you asked for at runtime, essentially, before the machine can be created. And an advantage of that is that it could be applied equally to control plane machines, which is currently the only place that failure domains are used, and machine deployments. So it's a different idea, but I wonder if, as an architecture, it might be a jumping off point.
Yeah, I mean, I appreciate the suggestion. I'll definitely go and read through that. I mean, it looks interesting.
Sorry, Matthew. Is this the issue or another one?
No, actually, I think you opened an issue ages ago, or not, a few months ago anyway, and you were asking for similar things, and I just wrote it as a comment against your issue. But I think it was yours, and you were just asking for ideas, and I threw that one in there.
Improve failure domain. Oh,
yeah,
okay.
that'll be it. That'll be it.
Okay, just for linking.
Thanks. I think what this is highlighting to me, and I won't take up too much more time because I realize we're getting into the meeting here, but like what this is kind of highlighting for me is that I think cluster API today works really great, right? It's a great way to like add nodes, remove nodes, to manage the cluster topology and everything. But where cluster API seems to, I think, have if I were to say like a weakness, for example, is in the type of predictive applications that want to try to look into the future of what's going to happen and then say, okay, if I look at this like one specific thing, like if I look at a machine deployment, how do I know what's going to happen with this in the future, right? Like what kind of node will this become? And that, obviously every different cloud provider has different details around what the actual instance types look like and the sizing and the options and everything. But there are some parameters that Kubernetes exposes or makes note of through well-known labels that are things that are kind of generic across all platforms, right? Like, for example, the well-known zone label. Now, I realize not every provider has a concept of zones like that. Like, notably like vSphere can be deployed in a way where we're not using deep zonal information, right? But it is this well-known label, and like many CCMs are expected to put some sort of zonal information there and whatnot. And so from a provider standpoint, like if I don't know what zone something's going to be in ahead of time, then it makes it more difficult to make predictive style calculations. And I think as cluster API matures, what we'll see is we'll probably see more people wanting to write day 2 applications that use cluster API. And so I think these are some of the areas where it might, having this information would be helpful to building those type of applications. But I realize this is kind of a future looking thing. So I'll step down off my soapbox now.
I think this is an interesting discussion. I think that the real point is, okay, what are the common properties that every infrastructure to surface? And the more that we become sophisticated, the more common properties we need. But yeah, we have to make the effort to define them. But yeah, thank you, Mike, for the great point.
Yeah, I mean, Fabrizio, I think you got it exactly. And just as a final note here, I think we know what these things look like in the cluster in the end in a generic way, because they all become node objects eventually, right? And the node objects have enough information to inform every other part of Kubernetes. So like the node object really has the info we need. It takes a lot of calculation to get there, right? So anyways, thank you.
Yeah, and the other part is that the node happens after the machine deployment. So we have a little bit of ordering to sort out. But okay, great discussion. Next one is Lubomir.
This is something that I've been following for a while. Kubeproxy maintainers from SIG Network are planning the release of a new V1 Alpha 2 API. Yes, the old one, V1 Alpha 1, has been out there for almost 10 years. It's an unfortunate ecosystem artifact that an alpha has been used in production for such a long time. kubeadm has been using it since epoch. People have been patching, editing, supplying kubeproxy in various ways. So this API is everywhere. Now, this I'm linked to the CAP and also linked to the work in progress PR and KK. So potentially we can skip this discussion until the KK PR merges, but I decided to bring it today, maybe because there are not too many agenda topics. For kubeadm, we already I started drafting a plan. How can I convince the rest of the maintainers with something that is feasible, and how we can migrate the kubeproxy configuration of that kubeadm stores inside the cluster, and also potentially also migrate configuration that the user supplies to kubeadm. And there are some ways to do that. The kubeproxy binary exposes a flag, which is something in the lines of write config to, and this basically does upconversion from V1 Alpha 1 to V1 Alpha 2, and it just writes it on disk. And kubeadm will likely spawn a job that. So first of all, kubeadm will upgrade the kubeproxy daemon set with the latest 131 version or whatever versions that supports this new API, and then we'll probably spawn a job that just does some mounting and magic to do conversion, and then we are going to populate this upconverted config inside the kubeproxy config map. So during upgrade, CAPI has to do the same, because CAPI today does not use the kubeadm upgrade apply mechanism. So this has to be executed somehow. And I have no idea. Maybe we should spawn a job first, but the job should be with a jobs node selector. It has to land on a particular maybe KCP node. So I open the conversation now with, do we have any ideas how to do that? And by the way, I'm open to own this work if we agree on a solution and a way forward, to write in a CAP or CAP or whatever people want.
Someone want to comment? Okay, first of all, Lubomir, thank you for giving an heads up. I have to take a look. Just a confirmation. Is this something that is going to land in 131?
The addition of the new API will likely land in 131. I think the PR has been in review for at least 2 releases, maybe. I think it's ready. One question I asked from the PR is, when is V1 Alpha 1 going to be removed? I think that's the bigger question. And
Yes.
My expectation and proposal as well was to treat it like a GA API. That's the least we can do, right? And that means 1 year deprecation cycle at minimum, maybe more, which actually lets CAPI kubeadm potentially have this for 1 more year. I would suggest that we proceed with a plan earlier than that. And by the way, the rules of API deprecation policy in Kubernetes, which is kind of vague and don't really apply to component config, is that when you introduce a new alpha, you can actually go ahead and remove the old alpha. But this, I was assume they will not do that. So potentially V1 Alpha 1 removed after 1 year, and V1 Alpha 2 is going to be released in this release, I think.
Okay, thank you. This is good information, and I think, yeah, let's hope that it does. V1 Alpha 1 does not goes away in this release, because this will be messy.
Yes.
Thank you again for raising this point. So I will update note later because I have the next point. The next point is about Kubernetes V1 Beta 4 types, which are in flight for V1.31. I have started a PR to implement those changes in cluster API. So I plan to do this in phases. First, I will keep the current cluster API bootstrap types as they are. They will just convert to the new V1 Beta 1, V1 Beta 4, sorry. And then we have to figure it out. I have a pull request, and I have also an issue. Let me link also this one to the thread where I'm discussing the change that can be introduced without breaking change or with breaking change, etc., etc. So the idea is that we can, and probably we should, introduce new feature that API brings in, with the caveats that they will be available only on 131 clusters. The tricky point that I'm trying to address is that in the new API, some fields are going away, especially timeouts, or are being moved to different struct. And so, yeah, I'm looking into how to make this transparent to the users as much as possible. So, yeah, heads up. There's a change happening. Question, comments? Good. It seems that we are already at the end at the agenda, which is which will give us back half an hour. If there are no last second topics, I thank you everyone as usual for the great discussion. See you in a week. Bye.
Thanks, Fabrizio.